Okay, this is our May, what day is it? May 11th? 10th? 11th? 11th. May 11th, and we're doing our volume final from grade 8, chapter 7. So I don't have it printed out here because I accidentally deleted the actual test physically, so we're going to improvise a little bit. The first question says, true or false, 1 liter of water is equal to 1 kilogram. Now this required a little bit of thinking. And the first thing you had to kind of show was that 1 liter is equal to 1,000 milliliters, and that 1 milliliter is equal to 1 cubic centimeter. So the first kind of metric understanding you needed to kind of write down for your true or false was that. And once we have that, 1 cubic centimeter is equal to 1 gram. We learned that with water. We should have said with water. I think it says with water. Yeah, of water. So therefore, 1,000 milliliters equals 1,000 grams, which is 1 kilogram. So our answer for this one is true. And there's kind of the idea that you needed to show why it was true, because 1 liter is 1,000 milliliters, 1 milliliter is a cubic centimeter, which is 1 gram. So therefore, 1,000 milliliters equals 1,000 grams, which equals 1 kilogram. Okay. The second question says 1 cubic centimeter is equal to 1 milliliter, and that's true. And the reason why that's true is because that's what our metric system is based on, right? So our metric system is based on the fact that a cubic centimeter of space will occupy 1 milliliter, which of course, if it's water, will weigh 1 gram. So the answer for that is true. Our next question says a cube with an edge length of 5 centimeters, so I'll just draw my cube, 5 centimeters, will have a volume of 250 centimeters cubed. Is that true or false? Well, all you had to do was basically sketch it out and say the area of the base, which is a square, multiplied by the height of the prism, will be 5 squared multiplied by 5, or 25 multiplied by 5, which will equal 125 cubic centimeters. So this cube will have a volume of 125 cubic centimeters. So therefore, the answer is false. False. It will not have a volume of 250 cubic centimeters. It will have a volume of 125 cubic centimeters. And question 4 says all prisms use the same formula to calculate the volume. The answer for that is actually true. They actually all do use the same formula, kinda. And you have to go back to when we said that the formula for the volume of all right prisms is the area of the base multiplied by the height of the prism. So that is technically the formula that you use for all right prisms. Now, it's kind of tricky because technically that's not the same for any of them. Because if it's a cube, you would use side squared times height, because that's the area of the base, that square. If it's a rectangular prism, it's length times width multiplied by height. If it's a triangle prism, it's base times height divided by 2 times height. And if it's a cylinder, it's pi r squared times height. So yeah, it's a kind of a trick question. It all does use the same formula, and that's the same formula. But depending on which prism it is, you would need to use a variation of that formula to solve for the actual volume. Question number 5 gives you a cube, and it says, what is the volume of this cube? So, Jolie, what is the formula for the volume of this cube? Side squared multiplied by the height, correct? Or, does anyone remember what the advanced one was we could use? We used it once, I think. We talked about it one time. Side cubed. Because side cubed means side times side times side, or 12 times 12 times 12, right? If we were thinking about it as side cubed. So you can actually say that, but we'll use the basic one. So once you substitute it, 12 squared multiplied by 12 is 144 times 12, which is, what was it again? 1756? What was it? I don't have the answer here. 1720, actually I have it right here, 1728. 1728 cubic centimeters. Now, here's the frustrating part. I might have said it every single time we did a volume question. Step 1 is write your formula. If I said that a quarter of you didn't write your formulas properly every time, I would be It wouldn't be hyperbole. It's true. Once you write your formula, substitute your information, and then solve it. I mean, there's only so many times a teacher can tell you to do that before he just says, you know what, whatever, do it your own way and lose marks. I don't care anymore. But you're supposed to do it that way, right? If you wanted full marks. Question number 6 is, what is the volume of this rectangular prism? So, again, it's a triangular prism, which means your formula is the area of the base. The base of a triangular prism will always be base times height divided by 2. And the height of the prism will be a capital H. Now, here's where it got interesting, because some people thought that the rectangle on the bottom was the base, but it's not. Because if I take this, what I should actually do, let's group this together. Let's group this together. Hang on, let's undo that first. Group it. Okay, group it right there. Let's rotate it. That's technically how you have to think of a triangular prism, standing on its triangle base, right? So if you didn't do that, you probably had a difficult time. So the triangle right here has a base of 4 and a height of 2 divided by 2. That's the area of the triangle. Now the height of the prism, if it was standing on that triangle, is not 2. That's the height of the face of the triangle. The height of the prism is 10. I would say half of you had 2 for the height of the prism, or 4. Definitely not 10. So 8 divided by 2 times 10, or 4 times 10, means the volume of that triangular prism is 40 cubic centimeters. Again, formula, substitute, simplify, answer. Question number 7 says, what's the volume of this rectangular prism? So we have a base that, if we were to kind of connect the dots here a little bit, your base would be this rectangle at the bottom here, right? So volume formula will be length times width multiplied by the height of the prism, or 11 times 2, which is the area of the base, multiplied by the height of the prism, which is 4. 22 times 4 means the volume is 88 cubic centimeters of space. And our last question on the first side for your basic question says, what's the volume of the cylinder? Our formula for this, Alexis, would be pi r squared multiplied by the height, or 3.14 multiplied by, if the diameter is 4, what's the radius? Anybody? 2. And the height of the prism is 5. 3.14 times 4 times 5 will be 3.14 times 4 times 5, which is 62.8. Is that the answer? I can't remember. Cubic centimeters for the volume. Question number 9 says, how much water is in this container? So the first thing I wanted you to be able to figure out is you need to figure out the volume of the full container. So again, it's a cylinder. So it's pi r squared times the height, or 3.14 multiplied by 4 squared, multiplied by the height of the prism, which is 10. 3.14 multiplied by 16, which is 4 squared, times 10. And just grab your calculator. Pi multiplied by the radius squared, multiplied by the height of the prism, is that right? I made a mistake somewhere. Let's try that again. 3.14, I think I might have done 314, times 16, times 10. I made a mistake again? Yes, I did. It should be 502.4, right? Is that right? Yeah, 502.4. Is that right? 502.4. That's the full volume. So that got you 3 points. The last part, which got you your extra points, was what is 3/5 of the full volume, or 3/5 of the full volume. The 3/5 is a decimal, is decimal 6. So 60% of the full volume is 301.44 milliliters of water. And that would be your final answer. Question number 10 says, this box has to be made out of glass. The glass costs 45 cents per square centimeter, and then that box has to be filled with a very expensive water, which is $1.20 for 10 milliliters. How much does it cost to make the box? How much does it cost to fill the box? So let's start with how much does it cost to make the box. The reason why we ask this question is because you have to know as a math student that if I'm going to make that box, I do not need to know its volume. I need to know its what? Surface area. And the formula for the surface area of a rectangular prism is 2 rectangles that make up the front and the back, and 2 rectangles that make up the top and the bottom, and 2 rectangles that make up the left and the right. Once you have that, the front and the back, the front rectangle is 20 by 10, so you have 2 20 by 10 rectangles. And at the top and bottom, you have 8 by 20s, so you have 2 of those, so 2 8 by 20s. And the left and right, you have 2 8 by 10s. Use that, you get the surface area. So 2 200s is 400. 2 160s is 320. And 2 80s is 160. Add those together, you get 700, 880. 880 square centimeters, not cubic centimeters of space, is the surface area of that box. Now, how much does 1 cubic centimeter cost? Right up here, it costs 45 cents for 1 square centimeter. So you take your surface area and multiply it by 45 cents. Grab your calculator. 880 multiplied by 45 cents means that the box will cost you $396 to make. Okay? So you're differentiating between volume and surface area. Now the second part is how much would it cost to fill, which is the volume. So we do not need any of this information anymore. Now we're going to go over here to volume. Since it's a rectangular prism, area of the base times the height of the prism will be our volume. The base is a 20 by 8 rectangle, so 20 by 8 multiplied by the height of 10 is 160 by 10. So the volume of this particular container is 1,600 cubic centimeters. Okay? Now I need to know how much it costs to fill. And if I look over here at the information it gives me, it says it's $1.20 for 10 milliliters. I'm going to make a quick conversion. If it's $1.20 for 10 milliliters, how much is it for 1 milliliter or per milliliter? It's $1.20 for 10, 12 cents per. Right? That takes into account our unit rate. When we did ratio and rate, that's just basically converting a rate into a unit rate, 12 cents per milliliter. 1 milliliter of water is equal to 1 cubic centimeter of space. So 1,600 cubic centimeters would be 1,600 milliliters would take to fill that container, right? And if each milliliter is 12 cents, we're going to take that and multiply it by 0.12, and that will be the cost of filling it. So 1,600 milliliters of liquid multiplied by the cost of 12 cents per tells me it is $192 to fill that box. Okay, our next question gives us 2 volumes, 2 prisms, and says which one will hold more and how much more will it hold? So asking about how much it will hold automatically tells you need to calculate volume. So the volume for a triangular prism is this. The volume for a cylinder is this. Even if you had no idea what to do, it's worth 7 points. Writing those 2 things down got you 2 out of 7. If you stopped right now, you would have got 2 out of 7, just by knowing what formulas to use, right? Now here's where it got tricky. If I took this triangle and redrew it over here, would you agree that's a fairly good facsimile of that top triangle? Okay. What's the base? 12. What's the height? 8. What number does not play into the area of that triangle at all? 15 is not a part of that area, is it? The base is 12, the height is 8. So therefore, when I substitute it, the base of the triangle is 12, the height is 8, divided by 2. Now here's where it gets a little confusing. What is that 8? Or that H right there? That H is the height of the prism. which is what number, Julioso? What's the height of that piece of cheese? How tall is that piece of cheese? Would you agree that's the number? Yeah. So the height of the prism is 10. I would say almost half of you missed up on your measurements there. You still had all the right work, but you put the wrong numbers in. 96 divided by 2 is 48. And 48 times 10 is 480 cubic centimeters of space, is the volume of the triangular prism. Over to the cylinder. 3.14 multiplied by the radius of 5 squared multiplied by 15 is 3.14 multiplied by 5 squared, which is 25, times 15. We just have multiplication left. 3.14 times 25 times 15. No, that's not right. 3.14 times 25 times 15 equals 1,177.5 cubic centimeters of space. Which one holds more? The cylinder. So circling the cylinder allowed me to see that you knew which one was more, or writing it as a sentence. How much more will be the difference between this? Take away the volume of the other, which is 480. It will hold 697.5 cubic centimeters more than the triangular prism. Okay, and that's all I needed to see. And our last question is something like this. How much water is in this container? It's actually quite an easy question, really. So, area of the base. What kind of base does a triangular prism have? It has a triangle, multiplied by the height. Now, if I redrew this triangle over here, it's a 4. Sorry, it's a 4. It's a 12. It's a 13. Of those three numbers, which one is not used in the area? The 13. So the base of my triangle face is 12. The height of my triangle face is 4, divided by 2. And the height of my entire prism is 10. So 48 divided by 2 is 24. 24 times 10 means the full capacity of that triangular prism is 240 cubic centimeters of space. But Calvin, it is only 9/20 full. What is 9/20 as a percentage? What's 10/20 as a percentage?
45.
That's right, 45%. So it is 45% full. All you had to do was take 9/20, so 9 divided by 20 to change that fraction to a decimal. 0.45 is 45%, so it's 45% full. 45% of 240 cubic centimeters is what your question should be. Grab your calculator. 45% of the full volume is 108 milliliters of water. And that's all you had to do.